Hello scholars, welcome. Mr. Hinkle here. Happy to talk about igneous textures. We're going to describe igneous textures and then I will show you the 7 distinct types of textures using words to define them, and then I've also got a bunch of rocks here to show you. So let's do the thing. Texture describes the physical characteristics of minerals that compose igneous rocks. Igneous rocks being rocks that form from the crystallization of a melt. Underneath the surface, they're intrusive. Above the surface, they're extrusive. Okay, that quick review will let us get into texture. So the very first texture that we are looking at is phaneritic. And phaneritic means coarse grains. When we see a rock that is coarse grains, we can interpret plutonic origin and say it is an intrusive rock. Granite has crystals that are visible with the naked eye, coarse grains, multiple different types of minerals, all about the same size. So, slow cooling history underneath the surface of the Earth. Phaneritic is our first igneous texture. Aphanitic. Aphanitic, when you have the suffix, I guess that would be the prefix, excuse me, a, it usually means without. So we're going to call aphanitic fine grains, meaning without large crystals. Here is basalts, commonly erupting at mid-ocean ridges, also certain volcanoes that have a high iron and magnesium content. Save that for volcanoes and composition. But in order to see the crystals in this, I would need to have a hand lens or a microscope. It's microcrystalline, meaning I cannot see it with the naked eye. And we interpret a rapid cooling, usually as lava erupting at the surface of the Earth. Cool. So what we've done is we've used texture to identify plutonic origins or volcanic origins, distinguishing these two rocks as either igneous intrusive or igneous extrusive. Okay, shall we keep going? What if it's both? What if there's crystals I can see and crystals I can't see? Well, we call this porphyritic. Did I spell that correctly? Yay! Okay, porphyritic, and this is going to be crystals in a matrix. And the idea behind porphyritic is that a melt that was generated in a magma chamber started forming crystals. And so I can see some of the crystals. There's a crystal, there's a crystal, there's a crystal, there's a crystal. But then this melt with crystals erupted onto the surface, and the rest of the rock cooled rapidly. So what you get are crystals called phenocrysts in a matrix called a ground mass. This is going to indicate 2 stages of cooling, likely at a volcano where crystals formed in the magma chamber, and then those crystals hitched a ride on up to the surface and erupted and in the lava. Porphyritic texture. Pegmatitic. So pegmatitic texture forms what's called a pegmatite. This is going to be very large crystals. When we see a pegmatite, we interpret there to be water in the melt at some point that, with slow cooling, created large crystals. So this crystal right here, it's about as big as my thumb. You can see this one right here, maybe as big as half of my pointer finger. So really large crystals that grow, commonly associated with granite in a water-rich environment. Okay, so maybe we're thinking flux melting. Maybe we're thinking An intrusion of a water-rich vein? Lots of ideas, but the large crystals of the pegmatite help us to understand, again, this is what textures are helping tell us, understand the geologic history of the rock. Glassy. You may know glassy from various types of, well, you know glass. Glass covers our houses, our cars, right? Glass is an amorphous solid that is actually created out of sand. But there are certain rocks, like obsidian, with a glassy texture. Now, obsidian is a rock and not a mineral because it does not have a fixed crystalline structure, which is a requirement of minerals. Minerals are naturally occurring from geologic processes, inorganic solids with a fixed crystalline structure and chemical composition, of which obsidian does not have that crystalline structure because of the rapid cooling. Often interpreted to have erupted in a body of water and be quenched almost instantly. Depositional environment. How cool is that? Pyroclastic. Let's see, I want another color here. What do we got? Pyroclastic. This is going to be volcanoes. So a volcanic eruption is going to produce its own type of deposits. Now, volcanoes are on the surface, and when they erupt and they deposit igneous, extrusive rocks because they're rocks on the surface. This is called a volcanic bomb because it is a chunk of lava that was hurled through the air, giving it its football shape, full of minerals that you can't necessarily see with the naked eye, but also a lot of rock fragments, and rapid cooling goes on in here. There's pumice, there's ash, there's volcanic breccia, and then let's see. Oh, I didn't bring the tuff out. Excuse me. You have different types of pyroclastic material. When that material is all welded together, we call it a welded tuff. Vesicular. Vesicles are air bubbles. So we talked about magma having three components: liquids or melt, solids, the crystals, and volatiles, which are gases. When there's a lot of gases in a volcanic eruption, those gases can be trapped in the cooling lava to create a vesicular texture. Now, vesicular texture has two types of rocks. We've got scoria, a very mafic, high in iron and magnesium, and pumice, felsic, high in silica. Pumice, this is like the pumice stone, like give yourself a nice little bit of exfoliation, right? All that good stuff. Natural material with human uses. We call that a resource. So vesicular is going to be our last type. Wait, 1, 2, 3, 4, 5, 6, 7. Our last type of texture. I mentioned this multiple times in the lecture, but igneous textures tell us the geologic history of rocks. They tell us the conditions at the time of formation, and they help us to understand cooling rate and where the rocks occurred. We've got, let's do the conclusion here. We've got phaneritic, aphanitic, porphyritic, pegmatitic, pyroclastic, vesicular, and glassy in order to describe our igneous textures. Thank you so much, and I'll see you again.